All right, so we're going to continue with our lessons on understanding the graphs of exponential functions. And in this particular segment, we are going to look at how the graph of the exponential function is related to the equation of the exponential function based on its vertical shift. So all we're doing is we're going to take the same ones we looked at in the previous lesson with possibly with reflections. Could be a normal exponential function, could be upside down, could be backwards, could be upside down and backwards. And then what we're going to do with these graphs is we are going to shift them vertically. It's called a translation. A vertical shift or a horizontal shift is referred to as a translation. So we're going to, in this video, translate vertically up or down the graphs that you have already learned to identify. All right, so let's first look at this exponential function here, this graph of this exponential function. The first thing I might ask you is to identify what is the equation of this graph. This is we haven't translated it at all. This is just like one that we have done in the previous lesson. So do you want to try and figure this one out just for a little bit of practice? All right, so we have, here's our horizontal asymptote. Now, I said in the last lesson, we were just drawing in the horizontal asymptote so that we could practice. This lesson is where the horizontal asymptote is going to become a lot more important. In this lesson, you're going to want to draw in the asymptote every single time, okay? But let's go ahead for practice. Let's go ahead and draw in the horizontal asymptote, which we can see, as usual, is going along the x-axis, right? And then we know that the point 0, 1, we're above the asymptote, which means that we're in the normal, location instead of being below. So we know that it's not negative. So this is going to be f of x is equal to, it's not going to be a negative in front of the exponential term. And now we need to find out, well, what is the base, right? And remember, we go over to 1 unit from here, 1 over, and then from the asymptote, we count over up to the curve. 1, 2, 3. And so this distance here is a distance of 3, and therefore the base of this exponential function is 3. Now, is it negative on the x? It is not, and the reason it is not because it goes flat to the left, and that is the normal circumstance. Only if it was flipped around where it's flat to the right and steep to the left would we put a negative on the x. So this is the normal shape of the exponential function, so we'll just put 3 to the x power, okay? Now what I want to do is I want to look at what's going to happen if this very same graph were to shift vertically, if it would translate vertically. And here's what I need you to understand, is that you can identify the vertical translation based on the horizontal asymptote, okay? So the horizontal asymptote tells you the vertical shift, okay? Shift. All right? So the horizontal asymptote is either going to shift up with the curve or it's going to shift down with the curve. And so if the horizontal asymptote is not on the x-axis, if the horizontal asymptote is down here at like -4, then that would indicate a -4 vertical shift of the curve. Now, where do we indicate a vertical shift on the equation itself, on the function? Well, what we do is put a plus or minus value on the end of the expression to indicate a vertical shift. Okay? Here's what I mean. Let's say that we did shift this down 4. 1, 2, 3, 4. That would be a -4 vertical shift. And we would know this because the horizontal asymptote, instead of being at y equals 0, it would be at -1, -2, -3, -4. The horizontal asymptote would be right here. And if the horizontal asymptote was down here, okay, what that would also mean is, you see this point right here, this 0, 1 point? It would also move down 4 units. 1, 2, 3, 4. And so instead of being at 0, -1, it would be at 0, or excuse me, instead of being at 0, 1, it'll be at 0, -3. So everything about this curve would shift down by 4 units, okay? And what we would do is, on the exponential function, we would simply put -4, okay? Let me show you what that's going to look like. I'll come over here, and I will change up this graph. Let's see here. And I'll put on a -4. And now you can see clearly it has shifted. It was up here. And now look where the horizontal asymptote is. It's shifted down 4 units. It's at -4, and sure enough, the graph goes through the point 0 and -3. But look what we can still do. We can still identify the base, and here's one of the most important things that you need to be able to do. We can still look at, identify the base of the exponential graph, but instead of counting from the x-axis up to the curve, we'll count from the asymptote up to the curve. So if we go here to where the horizontal asymptote is, we're still going to go 1 unit over from this very important point. I call this point, I call it the point. So if I say to you, well, where is the point? In this case, the point is at 0, -3. If you go 1 unit over from that point and then go to where go vertically along that where the horizontal asymptote is, and then count to the curve, 1, 2, 3. There we are. Once again, we have a base of 3. Okay? And so therefore, this graph right here, what we're looking at is 3 to the x power -4. Okay? Let's do another example, but let's do one with a reflection. All right. So here we have another one. If you want to, you can go ahead and pause the video and see if you can identify what we're looking at here. But I'm going to go ahead and do it now, if you're not going to pause the video. So here's the first thing I'm going to do every single time. The very first thing I'm going to do is I'm always going to draw in the horizontal asymptote. And so I can see that the graph is going flat right here, and that means that this is the horizontal asymptote. Okay? Now I'm not going to follow the curve, I'm following the horizontal line. Okay? Now, the next thing I'm going to do is, that's the first thing. The second thing I'm going to do is I'm going to plot the point. I'm going to go from the horizontal asymptote, I'm either going to go up 1 unit or down 1 unit. Up 1 or down 1. Okay? And it depends on whether the curve is below the asymptote or above the asymptote. In this case, the curve is below the asymptote, which means it's a reflection of the normal shape. Okay? So we know that there's going to be a negative involved somewhere. Okay? So I'm going to go 1 unit below the asymptote to this line right here. And I'm going to go along this line until I hit the curve itself. And I'm going to put a dot right there. That is the point. So I always plot the point. You don't have to write on there what the coordinates are, but you could count it if you wanted to. Okay? Then from that point, I'm going to go 1 unit over from that point. Then I'm going to go to vertically to wherever the asymptote is, which is right here. So this vertical line, 1 unit over, the vertical line that is 1 unit over from this point, that's the vertical line that I'm going to use to try and find the base of this exponential function. So I'm going to start at the asymptote, not at the x-axis. I'm starting at the asymptote, and I'm going to count vertically down to where the curve is. 1, 2. All right, there we go. So this is the distance between the horizontal asymptote and the curve where I'm 1 unit over from the point. Okay? Now, what is the length of that distance? That distance is a 2. That means that this exponential function has a base of 2. Okay? So we know that it's going to be f of x is equal to, and there's going to be a base of 2. Now remember, if it's reflected vertically across the x-axis, only now it's not being reflected across the x-axis, it's being reflected vertically across the horizontal asymptote. Okay? When it's reflected vertically, okay, upside down, we put the negative in the front of the function, right? if it was backwards, this is not backwards. If it was backwards, the flat part would be on the right side instead of the left side. Okay, so this is not backwards. So we're not going to put a negative on the x. So we're just going to have negative 2 to the x power. And now we need to determine what is our vertical shift. Okay, well, start at the x-axis and count up or down to where the asymptote is. So from here, we're going to count -1, -2, -3. So this horizontal asymptote is at -3. So we are going to put a -3 on the function. And this is now the equation of this exponential function. -2, or -2 to the x power -3. Okay? Let's do a couple more examples. All right, so here we have another example. If you want to go ahead and try it yourself, you can. But let's go ahead and jump right in. Here's what we need to do. We need to identify the base. We also need to identify the vertical shift. We also have to identify whether there are any negatives on the front or on the x, right? Any reflections, okay? First step every single time is to draw in the horizontal asymptote, okay? So we're going to draw in the horizontal asymptote. It's always going to be, you're looking for the place where the graph is flat, and then you're just extending that along the horizontal line all the way out, okay? The next thing we're going to do from there is we are going to move 1 unit either up or down, okay? In fact, let's go all the way over here and do it. From the asymptote, we're either going to go 1 unit up or 1 unit down, depending on whether the graph is above or below the asymptote. This graph is above the asymptote, so we're going to go 1 unit up from the asymptote to right here. Now we're going to move along that horizontal line until we get to the curve. Here's the curve, so that is the point. We're plotting the point. From that point, we're going to move 1 unit over. Now, you may ask yourself, how do I know whether I should move over? How do I know whether I should move over to the left or over to the right? Because I'm going 1 unit over from this point. How do I know whether I should go this way or this way? You do not want to go the direction where you're outside of the curve and the asymptote. You want to move in the direction where when you move your finger 1 unit over, your finger will be between the asymptote and the curve, whether it's above or below, okay? So we're going to move to this side where we're inside, we're between the asymptote and the curve. So we're going to move 1 unit over. Then you're going to vertically move to where the asymptote is, which is down here. And then along that vertical line, we're going to measure the distance from the asymptote up to the curve, which is right here. Now, you can see that the distance between the asymptote and the curve is about 1, 2. It's more than 2, but less than 3, but it's almost to 3. Hopefully by now, you remember what that means. That means that our distance is E, right? It's about 2.71828, okay? So the distance is E. Therefore, the base of this exponential function is E. So we're going to say f of x is equal to, now, is it going to have a negative in front of the E? Well, this graph is above the asymptote, not below. Therefore, it's not reflected vertically. Therefore, it's not going to have a negative in front of the E. So we're just going to put the E. Now we'll put the x, but we got to determine whether it's x or negative x. Well, remember, it's negative x if we have a backwards reflection, right? Our normal shape would be flat on the left and steep on the right. But this is flat on the right and steep on the left. So this has been reflected backwards. This one is going to have a negative on the x. So negative x. So it's e to the negative x power. And now the last thing we're going to do is we're going to do the vertical shift. And this is the easiest part in my opinion. I think this is actually easier than identifying the base of the reflections. Because all you're going to do is you're going to where the x-axis is and you're either counting up or you're counting down. In this case, we're counting up to the horizontal asymptote. From here, we're going to count 1, 2 units up. Because it's an up shift, that's a plus. So we're going to put a +2 on the end. And we're done. This is the equation of e to the negative x power plus 2, okay? Let's just do maybe one more example or two more examples. All right, we'll make this one our last example, and then we'll move on to the left and right translation, okay? All right, so we want to try and figure out what this equation is. Step one, every single time, is draw in the asymptote, okay? So the asymptote, it's flat right here. So right along this line, we're going to draw in our horizontal asymptote right along that X line right there. This one went cut a little bit low, so we'll fix that. There we go. We got our horizontal asymptote in. Then what we're going to do is we're going to go 1 unit either above or below the asymptote. The curve is below the asymptote, therefore we're going to go below. So from the asymptote, we're going to go 1 unit. And along this line, we're going to go to where the curve is. Boom, there's the curve. So we're going to put a dot there. That is the point, and that point tells us a lot of information. You could actually write the entire equation just based off of that point and the direction of the curve, okay? All right, now we're going to go 1 unit over from the point. Are we going to go to the right or are we going to go to the left? Well, if we go to the right, this is not between the curve and the asymptote, okay? This is outside of the curve and the asymptote. But if I go this direction, I have the asymptote above and I have the curve below. So therefore, this is the direction I want to go. So I'm going to go 1 unit over, then vertically, I'm going to go to where the asymptote is, which is right here. From right there, I'm going to identify the distance all the way down to the curve, which is right here. Okay, there we go. And this distance is 1, 2, 3, 4, 5. Okay, so this is a distance of 5. Therefore, the base of this exponential function is 5. So we're going to say f of x is equal to, now there's going to be a 5 in there. Now the question is there a negative in front of it? Well, remember, normally the exponential graph is above the x-axis, right? And so because this one is below, or sorry, not the x-axis, the asymptote. Because this one is below the asymptote, that means it has a vertical reflection, which means it has a negative on the front. So this is going to be a negative and then a 5, okay? Now, we need to know whether there's a negative on the x, right? Well, the negative on the x happens if there's a backwards reflection. Now remember, normally the graph is flat to the left and steep to the right. But this one is flat to the left and flat to the right and steep to the left. Therefore, this is backwards, so there's a negative on the x. So we'll say to the power of negative x. So this is negative 5 to the negative x power. Last thing we need is the vertical shift. Okay? So our vertical shift, here's the x-axis, and we have to go up to the asymptote. So that's going to be a plus. So we know we're going up, so there's going to be a plus. And how far are we going up? 1, 2, 3, 4 units. So it is a plus 4 shift. And therefore, the equation for this graph is negative 5 to the negative x power plus 4. And that basically is how you identify the vertical shift and where you write the vertical shift of an exponential function. Okay? In the next segment, we are going to learn how to identify leftward shifts and rightward shifts, or left translations or right translations of an exponential graph.